And good day, Algebra. We are kind of reviewing CO13. We talked about this last Tuesday. We looked at, Naveen, I'm teaching now. We looked at how, Naveen, I'm still teaching, warning for you. We looked at how negative exponents affect a base, and a couple of things I want to get out of the way. Does a negative power make a base negative? It does not. Okay, it does not. Here's what happens. We're going to recreate the chart that we had here. So if you weren't here on Tuesday, you can get a longer explanation of this in the video if you watch it. If you were here Tuesday, then this is just going to be kind of a recap. You know how on TV shows they always give you like a last time in whatever, last time in math class. So what is 2 cubed? 8. What is 2 squared? 4. What is 2 to the first? 2. What is 2 to the 0? Okay. And so what we looked at was we looked at something that we knew, something we understand, something we've seen before, right? We've seen 2 cubed, 2 squared to the first, and 2 to the 0. And we looked at the pattern developing here that as our exponent decreases by 1, from 3 to 2 to 1 to 0, what's happening over on the right? From 8 to 4 to 2 to 1. What's the pattern going on here? Dividing by 2, right? Divide by 2, divide by 2, divide by 2. Okay? And it's with patterns that when we come to something we don't know or something we haven't seen before, we can follow the pattern. Because chances are things are going to continue to go the way they have been. Okay? When we got down to 2 to the negative first, what was our value? What is 2 to the negative first power? Cool. 1/2, right? Or 0.5. Again, you're dividing that value by 2 as we move down the line. As we decrease our exponent by 1, the pattern is divide by 2. So 2 to the negative second power is what? 1/4. 2 to the negative third power is 1/8. And then we looked at it in terms of expanded form, and we said this makes perfect sense. Because if 2 cubed, well, maybe not perfect sense, but if 2 cubed is 2 times 2 times 2, into the negative third, it's just 1 over 2 times 2 times 2. Right? If 2 squared is 2 times 2, 2 to the negative second power is just 1 over 2 times 2. And we said that the rule for this is that what a negative power does is it takes that base and it moves it to the other part of the fraction, right? 2 to the negative third power is in the numerator of this fraction. We don't have to write the over 1, but it's still there. What it does is it takes the base and the power and it moves it to the denominator and becomes 2 to the positive third, or 1 over 8. Right? Doesn't make the base negative, Sam. Okay? It takes that base and it moves it to the other part of the fraction. So just because I made an extra line here because I can't count well, what's 2 to the negative fourth? 1/16, right? 1 over 2 times 2 times 2 times 2. Edward, do you have your binder with you? Go to your locker and grab it. Everyone else need to go get their binder? No? Nathan, go grab your binder. You have it? Good stuff. Chase, you lied to me just now. Okay. All right. So then we kind of summed it up here in the rule down below. I don't remember how far. Did we actually get this far? No? Okay. Nathan, what do you have written down? Yeah.
Coefficients stay the same.
Okay.
Exponents move to the opposite, like up and down. Opposite up and down. The base moves with the exponent.
Okay. I'm going to change that coefficient line of stay the same to stay put. Okay. Because the negative power rule is all about what do I move and where do I move it to. So the coefficients, they stay put. They do not follow the base because it's a coefficient. They're not attached to the power, right? Everything's good with them. Okay? The bases move to the other part of the fraction. The bases move to the other part of the fraction. The exponents move to the other part of the fraction as well. And what else happens? They become positive. If you're having a bad morning, sometimes a change of scenery is all you need, right? You don't like the numerator? Go down to the denominator. You'll be happier there. I don't know. But it moves the other part of the fraction and it becomes positive. The base follows that exponent wherever it goes, but the base stays the same. The base does not become negative, doesn't change, it just moves. And that's, I think, where we stopped. Yes? Yes. Okay. Questions on this? Again, longer explanation in the video from last week, but this gets you all the information that you need. So 7n to the negative third. Okay? What's being moved? We'll start there. What's being moved? What's got the negative power, Caitlin? The n does, right? Not the 7. 7's the coefficient. That's all good. But it's the n to the negative third. So we're going to move this to the other part of the fraction. We're going to move it down. And so in our answer, what's still in our numerator? What didn't go anywhere? What stayed put? Will, the 7, the coefficient. That's still up top, right? And now in our denominator, we got our n to the positive third. Okay? N to the positive third. And you're done. That's all you knew. Right? 12x to the negative ninth y. What's being moved? Cole. Yep, just the x to the negative ninth. The 12 is a coefficient. It stays put. The y, what's the power of the y there? 1. It's not written, but it's there, and it's a positive 1, right? So that stays put as well. You're only moving those negative powers. So on our answer, we've got the 12 and the y still up top, and the x to the negative ninth goes down to the denominator and becomes x to the positive ninth. Okay, yeah? What about the y, though? No. If it has a 0 above it, it is a 1. If it has a 1 above it, it is legitimately there. We do have a y. Okay, we do have a y. Well, again, a lot of rules, right? It's just, you gotta, yeah. The next one, 2 over 3n to the negative fifth. What gets moved? Sam? The n to the negative fifth, right? And where does that move to? Too much negativity in the denominator, so go to the numerator, right? Goes to the numerator. Everything else stays exactly where it's at. The 2 is still in the numerator. The 3 is still in the denominator. But now that n, base of n, joins the 2 up top, and it's a positive 5, and the positive fifth because we moved it. Okay. Next one, t to the negative third over c to the negative 10th. What gets moved? Everything does. Our t to the negative third, unhappy in the numerator, goes down below. The c to the negative 10th, unhappy in the denominator, that goes up top. Becomes c to the positive 10th and t to the positive third. Initial questions on this one? No? All right, cool. Go through the next 4. Try it on your own or with the person you're sitting next to. Check your answer with the person you're sitting next to. Just follow the rule, okay? I'll pause the video. We'll come back to it and talk about it. And we'll go from there. Here we go. Okay, so 1 over h to the negative first. Who wants to share the answer they got for this one? 1 over h to the negative first. What does that simplify to be? Izzy? Sure. You could move this h to the negative first up to the top. So you get h to the first. You're left with a 1 in your denominator. Do we have to put all those frills on there, though? What ultimately does... It's fine if you do have it, but how else could you write this? Eli? H over 1, sure. How else could you just write this? Caitlin? Just H. Okay, all those extra ones, well, they're not wrong if you have them there. They're not necessary either. Okay, it is just H. Who wants to share their answer for the next one? 18, a to the negative fifth, b, c to the negative first. Paisley. Okay. So when the power is 1, you don't have to write it. When it's negative 1, you do, to show that it's a negative 1, right? Show that we have to move it. But yeah, our a to the negative fifth goes down to the denominator. Our a to the negative first, or sorry, c to the negative first goes down as well. We're left with 18 and b up top. They don't move, right? And then a to the positive fifth and c to the positive first. Next one. Who wants to share? Anybody? Colin.
A squared n to the 7th over b9 y to the 11th.
Good. Our b to the negative 9th and n to the negative 7th move, right? N to the negative 7th goes up top. B to the negative 9th goes down on the bottom. And our a squared and y to the 11th just stay put because I got positive powers. They're happy right where they are at. And last one. What'd you get for this one? Who wants to share? Tristan, boys. Shh.
I got 4y squared over
Good. 4y squared over n squared is correct. The 4 and the y squared stay where they're at. N to the negative second goes on down. And we have 4y squared over n squared. Eli.
Problem 3 of the bottom row, does it matter the order that we put in, like the B9, Y,
There's debate whether exponents should be written from greatest to least or alphabetically. Greatest to least power is probably better, actually, but right now I'm not really concerned about that because I just want to get the rule down. The order you put it in doesn't really make a difference to me. We will get to standard form for exponents in like CO42 or something like that, so it's out there eventually. But for now, no, I don't care about the order. Good question. Anything else? Whoops. Okay, your homework for tomorrow is the second page, which is all review. It goes by objective. So the first row is CO10, the second row is CO11, third row is CO12, and then the fourth row is what we just did, CO13. So if you need to look back, please do so. This is a good litmus test for where we are right now. We're about halfway through the unit, a little more than half. How are things going with all these rules? So far, I've thrown 4 of them at you. Okay, if your response is things are not good, then do what you need to do to fix that, right, before the test comes. It's just a matter of practice. It's a matter of reviewing. It's a matter of reading through your notes again. Okay, it's a matter of class attention, right? Lots of things, lots of factors going in. But yeah, Sam, do you have your hand up? Oh, thumbs down. Well, let's turn it around. Okay, negativity into positive. Okay, that's helpful. Thank you. All right, with gusto, that's how you math.